Okay, in this video we're going to take a look at an example of a radical equation that has two roots. We're going to solve this equation for the variable x, okay? First step is to isolate one of the two roots. I am going to choose to isolate this one because it has a positive coefficient. This one's negative. Moving it over will make it positive, okay? So we take this whole term right here and we add it to the other side. I'm going to put it behind the 1 instead of in front of it just to keep from being confused about whether 1 is underneath that radical or not, okay? I kind of like to put them behind. So square root of 3x minus 5 is equal to 1 plus square root of x plus 2, okay? All right, second step is to square both sides. Now this gets a little tricky when we have a root that's got a term attached to it, like this 1 plus the square root of x plus 2. So really watch what I'm going to do when we do that one, okay? Now squaring this first one's no big deal. This is just a single term right here since it's all under that root. And so to square it, we're going to get rid of the root. Oops. Okay, so we get 3x minus 5 when we square that side. Now, squaring the other side, we will actually multiply that. It's not really a binomial, but it looks like a binomial, and it's going to act like one, times an exact copy of itself, because what the square there means is that you're multiplying what's in parentheses by itself. You cannot distribute the square to these two terms. It doesn't work that way. Exponents are not distributable over addition or subtraction like they are over multiplication or division, okay? So we've got to multiply those two out. It's actually a lot easier than it looks. It just involves a little bit of concentration to keep up with where you are, okay? So first we do the first terms. I'm going to follow full. So we do the 1 times the 1. And then the outer terms is just 1 times that root. Inner term is going to give me the same thing, the root times 1. Oops. And then we have the two roots multiplied together. So when you do that, when I multiply these two together, it's the same thing as squaring just that root because they're identical, okay? So what happens is we lose the root and we just have the two terms, x plus 2, okay? If you need to see a little bit better that they came from the same thing, you can put those two in parentheses. It doesn't really make that much difference whether you do or not. All right, now let's continue to simplify a bit. We still just have the 3x minus 5 over here. But I've got two constants. I've got the 1 and the 2 that I can add together there. So that's going to give me a 3. I like to move this x up front too. And then we have the two radical expressions right here that are identical. So since they're the same radical, I can add those together and just get 2 on the square root of x plus 2. Now what we're doing is kind of heading towards isolating this radical. Okay, it's the one that we have left, so this one's got to go next. I've got to get rid of this one too. So I want to move my 3 and my x to the other side. Now the 2 can stay put. Okay, we can leave that one alone. But I do need to move the x and the 3. So subtract x from both sides, and this will be a 2x. And then if I add, subtract 3 from both sides, that's going to be negative 8 is equal to 2 on the square root of x plus 2. Now, with the terms the way they've turned out here, we actually could divide through by 2, and it would clean things up a bit. So we can do that, or you can leave it attached to the root and just square it with the root. That works okay too. But since it's going to come out so nicely, I think what we'll do is just divide each term by 2, and that will allow us to cancel those and just get rid of them. These will cancel also, and these two will cancel, leaving me with a 4. So I'll get x minus 4 is equal to the square root of x plus 2. We square both sides again. And once again, I do have a binomial right here that I will square. So that's going to give me x minus 4 times x minus 4. Didn't really mean to do that in red. That's going to be equal to x plus 2, because when you square a square root, you just lose the root, okay? So if I multiply this out, the x times the x, I get a negative 4x for the outer and a negative 4x for the inner products. And the negative 4 times negative 4 is positive 16. We do have a quadratic, so we will need to move the x plus 2 over to the other side, set it equal to 0 so that we can factor and solve. Negative 4x minus 4x is going to give me a negative 8x for these two. And then when you move this x over, let's see, that is just an x. And then I'm just double checking myself to make sure here. So we're going to have negative 8x plus 1x, so I get a negative 7x. And then if I subtract 2 from both sides, that's going to give me 14 right there. Equals 0. Ooh, I caught a mistake. Okay, this is supposed to be a 9 right here, because that would be negative 8 minus x. When I move that x over, I apologize. So that should be a 9, okay? And when I factor this, we need 2 factors of 14 that will add to give us negative 9, okay? So that would be a negative 7 and a negative 2. That gives me 2 answers, 2 solutions. X minus 7 will give me 7, and x minus 2 will give me 2. And you do have to check them, okay? Just like you do for any of the other radical equations, you do need to check these. So we'll need to go back to our original problem. Okay, so here's our original equation that we started out with, and we are checking the positive 7 first. So I'm going to have the square root of 3 times 7 minus 5 minus the square root of 7 plus 2 equals 1. 21 minus 5 is 16. 7 plus 2 is 9. So 4 minus 3 equals 1, and that's a true statement. So we've got that 1 equals 1, and that means the 7 works. So we keep the 7 as a solution. Now let's try the 2. Whoops. I erased a little too much there. Alright, so if we do the 2, here's our equation again. And I plug just a positive 2 into it, so that's going to be the square root of 6 minus 5 minus the square root of 2 plus 2 is equal to 1. So that's the square root of 1 minus the square root of 4. And square root of 1 is 1 minus square root of 4 is 2. Uh-oh. That one doesn't work. Okay, so here's what we do when we find a solution that doesn't work. Those are called extraneous solutions, and we just simply mark them out. Okay, we can't use that one. So if this was a Web of Sun problem, your only answer would be 7. You just enter 7, and that would be it. Okay.